well, what we're going to talk about today is we're going to talk about integration by parts. We have a lot of students sometimes get confused with this, so I'm going to make a couple tutorials on how to solve different equations, explain integration by parts, and how to solve some problems using integration by parts in this tutorial. So, without further ado, first off, what is integration by parts? Well, essentially, when you integrate, you are doing a reverse derivative. You're finding antiderivative. Now, the U substitution, when you talk about that, that one breaks down the chain rule. Well, integration of parts breaks down the product rule. And here's, I'm going to show you a little proof on how to do this. Well, when you use the product rule, all right, you're going to take the derivative of the first, which in this case is U, times V, plus derivative of V times U. All right, so what you got right here is this expression. So if I would take this right here, and I would integrate that, that would essentially equal U times V of X. You can see that right there. Now, if we break this up, since we have our addition, we can break it up to two different integrals. So we can have the integral of V of X times U prime, plus the integral of U of X times V prime. And then from here, we can break this up a little bit more. I can subtract this one right here, the integral of V times U prime over on the other side, and we have the integral of U of X times V prime of X. And that is essentially where you get the integration by parts, where you have a lot of books will say U times V minus the integral of V du equals the integral of U dV. All right, du mean the derivative of U and dV mean the derivative of V. So what we have is an integral of U times dV. And what we need to do is we're going to break this down into a simpler integral so we can actually solve it. Now, the key thing when you use integration by parts, just like when you use U substitution, is you need to pick what is U and also decide what is dV. Now, this is where I go a little bit different than other teachers because I have a little acronym to help us identify what is U and dV. So, well, we're going to kind of create a hierarchy of different functions that are easy to integrate. So the ones on the bottom are easy to integrate, like exponential, trig, algebra, inverse trig, and then logs. Logs are the hardest to integrate, and we just don't like doing it. Actually, we don't do very much of it, and so that's why we keep them on the top. So what we have is U is going to be either a log, an inverse, an algebraic expression, or power function, trig, or exponential. And so I say is light. All right, little integrals always taste excellent, and that's going to help us pick our U. The other value that we have over here is going to be our dV, so that is what we're going to do in these problems. So the key thing is picking U, dV is going to be our derivative, and let's do this. All right, so let's take it up. Well, here is an easy one. We have the integral of x cubed natural log of x dx. All right, so this is what we're going to do. We're first going to take, and we're going to decide what is our, all right, U going to be. And what I'm going to do is I'm going to create a little box. This is different than what other people do, so I do a little box right here. So we're going to have U in this box, and dV is going to be right here, all right, in the lower left-hand or the right-hand corner. And we first have to pick U. Now, according to light, we're going to pick whatever is the hardest one is going to be U. So in this case, we have a log and natural log of x. So I'm going to put that right there. Natural log of x. And our another one is going to be then our dV. Well, what's left over is our algebraic expression, which is x cubed. Now, according to integration by parts, all right, according to integration by parts, we need to take U times V minus the integral of V times du. Well, I have a special way of figuring that out because first off, we need to figure out du is. Du is the derivative of U, so that's going to be 1 over x. That was pretty easy to do. And then we're going to find out what V is, all right, by taking the integral of x cubed because we have to go and integrate this derivative in order to figure out V. So that's going to be x to the 4th over 4, and that is going to be our V. Okay, so once we have that, now I say is we're going to use magic 7, our magic 7. I create a magic 7. What that means is we're going to take U times V. So I'm going to have x to the 4th over 4, all right, times natural log of x. All right, that's the first part of our 7, U times V, minus now the integral, all right, that's the integral symbol, just so everybody knows, all right, V times du, all right, V times du, so that's the last part of the 7, so U times V, magic 7, V times du. So then we have x to the fourth over 4 times 1 over x. And we'll have dx right there. All right. What we just did was we used the integration by parts, which is the reverse product rule. We have our u times v, magic 7, all right, minus the integral of v times du. All right. From here, we're going to simplify this. All right, I'm going to have this right here. We have 4. We have the natural log of x right there. We're going to have minus. Now I'm going to simplify this right here. I'm going to take the 1/4 out of this integral. All right, so we're going to do a third integral symbol. I'm just going to turn to x to the third dx. And now we have an easy integral to integrate. And so I'm just going to finish this up. You probably can do it in your head pretty quickly. All right, natural log of x minus, we have 1/4. And we take the antiderivative of this, which is going to be x to the 4th over 4. And we're going to have plus c, all right, because we don't have a definite integral. Bada bing, bada boom. All right, we can write our final simplified answer. All right, we can factor out a x to the 4th if we wish. I wish. All right, what I have left over then is natural log of x, all right, minus 1 over 4. And that's all plus c. All right, and that, my friends, is integration by parts. The key thing is picking u, light, and then I use the magic 7 to help me remember the order in which we write out integration by parts. All right, well, if you want to try, I'm going to do one more, and then I'm going to save a little time, and we're going to do, I'll do another one in another tutorial. So I'll do one more here, all right, if you got time. And here we go. We have x times sine of 3x. Now, just a little side note is that you don't want to use integration by parts right away, okay? Obviously, if you're doing your homework and all of it's integration by parts, you're probably going to do integration by parts all the time. However, the first thing you always want to see is you want to see if you can use substitution. U substitution is the easiest, or just a basic integral. Well, in this case, if I were to use U substitution, I probably am looking at, all right, I don't know, 3x or x. Well, that doesn't help me out because that doesn't cancel anything else, and I don't create an easy integral. So next thing I see x times sine of 3x. So that kind of leads to parts because remember it's a breaking down of the product rule. All right. So since we're breaking down the product rule, that's u times dv. All right. I'm going to use parts in this case. All right. So I'm going to set up my little table. I'm going to have u. I'm going to have dv. And so first thing I'm going to pick my u. Remember, light. Little integrals always taste excellent. So what do we got here? Well, little, we don't have a log, we don't have an inverse, we don't have an, we do have an algebraic. All right, algebraic is going to be my x right here. All right, you don't have to always do x, but it just keeps it simple. All right, fast and efficient when you do this. And next one I'm going to use my other function is going to be my dv. All right, we're going to find my du by taking the derivative of x, which is 1. We then find our v by taking the antiderivative of sine of 3x, which is going to be negative cosine of 3x all over 3. Room here, sorry about that. All right, and then we're going to use our magic 7. Woo! I like doing sound effects when I do math, of course. I want you. So what we have is u times v. So what we're going to have is negative, all right, x cosine of 3x all over 3. Nope. All right, minus integral. Finish the magic 7. U times v minus integral of v, which in this case is negative. All right, cosine of 3x over 3 times 1. All right, and we have dx right there. Okay, well, we just did it. Once again, took a very difficult integral, made into a simpler integral. Right here, I'm going to cancel this out. So we have negative x cosine of 3x divided by 3. We're going to have the negative makes a positive. We then have a cosine. We have to bring the 1/3 and bring it outside. We take the integral of cosine. Integral of cosine is sine of 3x. And then we have to divide that by 3 again. So we got that. And we got to add our plus c. Bada bing, bada boom. All right, that's what I say. So what do we got here? I can factor out a 1/3 if I wish, and I wish. I have a negative x cosine of 3x. We got a plus a sine of 3x whole over 3. And right there, I'm going to plus a c. I believe I did everything right. Yep, it appears I did. All right, awesome. All right, and that's what we got. So that's our answer. We can box it. Put a little bow on that. Wrap it up nice and neat. Yeah, I'm a little weird. I apologize. But that's how you use integration by parts. All right. Key thing, reverse product rule. Find the U. Use this little acronym. It helps you out, makes things life really easy. All right. First one, look for a log, inverse trig, algebraic or power function, trig function. All right. And then exponential. That's the easiest function to integrate. But that's a U. The other function is going to be dv. Make sure you only use parts when you have u times v, two functions being multiplied, and you can't use u substitution. I will repeat, only use parts if you can't use u substitution. All right, you should write this down. Only use parts when u sub fails. If you don't do that, you will fail. All right. Yeah. All right, so with that, I hope this helps you out. I will do another tutorial doing some more integration by parts in a little bit, but hopefully this gets you started. All right, good luck and God bless.